So far what we have done, well, we have created the wind tunnel and then we have put in the CAD model and then you assign the boundary conditions. What is the boundary condition that you typically assign? Well, at the inlet boundary, you basically say what is the flow speed, which you can measure. It is basically whatever the speed of the air is basically going to be equal to the speed of your vehicle. So if it's 30 km per hour, then that is going to be your inlet velocity. Now, from a CFD point of view, it makes more sense to provide a mass flow rate boundary condition than provide a velocity boundary condition. Not saying that velocity boundary condition is bad, but your CFD solver sometimes behaves well if you provide a mass flow rate boundary condition. What is the difference? Well, instead of providing the value for velocity, you are providing the value for rho times A times velocity, where rho is the density of air, which is typically around 1.2 kg per meter cube. A is going to be the area of the wind tunnel, all right, which you're setting it up. Since it's a rectangle, you can calculate its area very easily. And then V is your velocity. So this would be 30 km per hour or 80 km per hour. And this should be your inlet conditions. Okay, I hope that makes sense. At outlet, what do we specify as the condition? Can anyone tell me? So what do I mean by outlet? So if I go to my setup, CFD setup that I had on the other screen, and let me clear all my annotations. So here, if you look at this guy, this is a very simple setup though, but proves a point. So this side is my outlet. What would be the boundary condition at this point or at this phase? Can anyone tell me? Atmospheric pressure, when air is flowing over the car, what's going to happen in the backside? Pranjal Kumar, inlet and outlet velocity should be approximately the same. Your velocity will be calculated. It makes sense to provide the pressure. So if you have a lower pressure, then what should that value be? The answer to that question is you don't know, right? Because that is what you want CFD analysis to say. If you know that pressure, then you know everything about your car. If you know the pressure upstream is your stagnation pressure, and behind it, if you know the pressure, then you can just do a delta P and calculate the pressure drag right away. The problem is you don't know the delta P. So what you do is, and this is a very important step in CFD analysis, is you create a wind tunnel that is actually sufficiently long. It has to be sufficiently long so that what's going to happen, your wake region is going to be present, but then there's going to be a decay there. And at some point, you are going to be ending up with free stream conditions. And at this point, it is safe to say that, you know what, my pressure is atmospheric pressure. Does this make sense to everyone?